Welcome. My name is John Vignoki. I work with a company called C3IoT, and I'm excited to be introducing best practices using big data on AWS. So before I introduce Bob and Ranga, I just want to tell you quickly about C3IoT, who we are, what we do. We've been built on Amazon from day one, 2009, when we were founded. And what we do is we provide a platform as a service, a software platform for big data, predictive analytics, and IoT applications, and helping you leverage the power of the AWS infrastructure and services to actually solve real-world business problems. Not just identify insights using machine learning, but also operationalize those insights into front-end user applications. So the way we do that is we actually started selling our own applications, which you can see on the kind of the top left corner. Predictive maintenance, fraud detection, sensor health, CRM. But quickly our customers started wanting to use our platform services to actually build custom applications that did things like inventory optimization, supply network risk, connected home. So we've exposed our platform as a service, which includes everything from data integration all the way through storage, processing, metrics, machine learning tools, full set of APIs, application logic, UI services, deployment management, and monitoring services. So our customers can build these next generation applications which apply machine learning at scale. And in order to do that, we leverage a lot of the great work that AWS does. Everything from S3, DynamoDB, RDS, Redshift, to EC2, EMR, Kinesis, AWS IoT, Greengrass, and many of the other services that are in the pipeline. So I'm excited to be introducing Bob here. So Bob, we're good. I was supposed to take 5 minutes, but we'll just cut right to the chase here.
Great. Thanks, John. Hi, everyone. My name is Bob Griffiths. I'm a Solutions Architect Manager for Public Sector at AWS. In this session, I'm going to start out by giving an overview of the AWS Big Data Services. I'm going to go relatively quickly. This is just going to be a survey of the services for awareness. It's not a deep dive. I'm going to go relatively quickly because I want to hand it off over to Ranga, who's joining us from FINRA, and he's going to give an overview of how they're doing their market regulation on top of AWS. So specifically their data storage and management in S3, their use of EMR, and their use of Lambda for data validation. So again, I'm just going to go through a very quick overview. We will try and make time for questions after. So if we can get through all the content, there's a lot of content, so we'll be going through the slides relatively quickly because I think you guys will probably be very interested in what Ranga has to present. So we're going to try and set aside time for questions. If we run out of time, we'll also be around. We'll stand outside the room so the next session can get ready. We go outside the room, outside the door there, and we can take follow-up questions out there as well. All right, so let's start out with just a basic question is what is big data? There's lots of definitions for this. So I like this one. When your data sets become so large and complex, you have to start innovating around how to collect, store, process, analyze, and share them. I like this definition because it doesn't say anything about big data is 10 petabytes or 500 gigabytes or 3 exabytes or whatever. It could be different for your business. It's just whenever you get enough data that you have to start innovating and thinking about these things to manage your data sets. So I want us to use that as a rough big data definition for this. All right. So this is a bit of an eye chart, and it's going to become more of an eye chart as time goes on because we keep innovating and adding new services. But there's one point I want to make. I'm going to make this point a couple of times throughout my part of the presentation, and that is don't be overwhelmed by this chart, or just generally speaking, don't be overwhelmed when you go into the AWS Management Console and you see like 90 things on that front page. If you're new to the cloud, that can be very, very overwhelming. I know when I first started working for AWS and I was looking at that, I was just taken aback by how much stuff there was to learn. So you might look at this and say, oh, look at all these services we have to collect, store, and process and analyze big data. That's a lot. It's overwhelming. I don't want to worry about it. But I want you to take away the message, at least from my part of the presentation, is you don't have to start with all this. You can start with just one or two of these core services and actually start doing foundational, fundamental big data work in your organization. So we provide this whole suite of tool set to give you the right tools for the right job, and you can pick the right tools for the right job. But start small, start with 1 or 2 services to get started, and then enhance and add on to that. So I'm not going to go through this slide. I'm going to have the following slides will go into some of these in a little bit more detail. But this is just to give you an idea of the types of tools we have to collect the data, to store the data, and then to process and analyze the data. So again, if you take nothing else away from this presentation, just remember that you don't have to do all of this to get started. Pick one service, add on another service, and then build on top of that. And you can even grow that one service that you pick. So if you don't remember anything else, remember that. All right, so let's start talking about S3. There's a reason why we're starting with this one, because when you talk about big data on AWS, it's pretty much going to be guaranteed to be using S3. This is where you should probably put your data. So in S3, you can store anything. It's object storage. It's highly scalable. It's designed for 11 nines of durability. I'm not going to count the nines. There should be 11 up there. This should be the foundation of your big data in AWS. So when I say pick 1 or 2 services, this is one of the ones you should pick. As part of data collection, this is one of the most popular services because this is one of the very few services that we have that you can actually physically touch. You know, the AWS cloud is kind of nebulous. It's all this kind of stuff sitting out there in these faraway data centers in US East and Sydney and US West and GovCloud. And you know it's kind of out there, but you can't touch or feel it. This is a very popular service because it's one of the few things you can actually order and it will ship to you, and you can actually touch it and put data on it. So Snowball is a service to allow copying of data onto this physical device, sending it to S3, and then we will offload that data into, send it to AWS, and we'll offload that data into S3. So for very large data sets that would take very long, weeks, months, years to copy over an internet connection or even a direct connect connection, this is a very good option to ingest that data much more quickly. You can order multiple of these, load them all up, send them to AWS, and we'll load them in your S3 buckets, and you're good to go. It's ruggedized. It has an e-ink shipping label built into it, and it can do 50 or 80 terabyte versions and 10 gig networking on it. All right, next one, Redshift. This is our data warehouse service. It's a relational, massively parallel database. It's columnar storage, petabyte scale. It's fully managed. You can do both hard spinning disk and SSD varieties. And it starts out at 1,000 terabytes per year, $1,000 per terabyte per year, sorry. So data warehousing. Again, I'm going very quickly. This is just an overview. Next, EMR. So just one quick side note on EMR. I don't like the name. Back when this was named, it stands for Elastic MapReduce. That's back when Hadoop was basically MapReduce. There wasn't else much on the platform. But today, Hadoop is much more than just MapReduce. It's Spark, Presto, Flink, HBase, Hive, Tez, Oozie, all kinds of things you can run on Hadoop. So EMR is really a managed Hadoop service. So it's called Elastic MapReduce, but you can think of it as managed Hadoop. And anything that you can run on your on-prem Hadoop clusters, you're going to be able to run on EMR. But the advantage with EMR is it's easy to use, fully managed. You can script it or just click a few buttons in the management console and get a very large EMR cluster up and running in 10, 15 minutes, something like that. It supports on-demand and spot pricing. And it also supports, importantly, S3 as a file system. Of course, it supports HDFS, which is the standard Hadoop file system. But we also support S3 access directly from EMR, which goes back to my point, you should be putting your data on S3. Athena. Athena is serverless, semi-structured, unstructured queries. So it's similar to Hadoop in that it's a cluster of servers behind the scenes actually querying data living on S3, which you could also do with EMR. However, Athena is serverless, so instead of having to spin up your own EMR cluster to do this, you can just use Athena. So if your data lives on S3, again, which you should probably be doing, you can use Athena, zero infrastructure, zero administration, totally serverless. you can use standard ANSI SQL, standard ANSI SQL, to query data living on S3 using Athena. Elasticsearch, excuse me. Amazon Elasticsearch service is a managed Elasticsearch service based on the open source Elasticsearch project. So if you're already using Elasticsearch on-prem and you have it up and you have it managed in that system and you're using the APIs, those same APIs work with this managed service. It's the same product, just run in a managed environment. So it's very good for distributed search and analytics. Our version also comes pre-packaged with Logstash and Kibana built in. Logstash integration and Kibana in the console. So you get that full ELK stack, Elasticsearch, Logstash, and Kibana as a managed service. So it's very good for log analytics, full text search, application monitoring, and more. All right, Lambda. This may not be an obvious one. Lambda may not be the first thing you think of when you think of big data on AWS. You're probably more thinking of Redshift and EMR and S3, and that's traditionally what it's been. But don't forget about Lambda. Lambda is our serverless compute product. And there's probably other deep dive sessions, hopefully you guys will be able to attend, that go more into detail on Lambda. In fact, Fannie Mae had a presentation somewhere in the past couple of days that talked about their use of Lambda for big data, where they replaced an on-prem HPC environment with Lambda to do thousands of simultaneous Monte Carlo simulations. And the nice thing about Lambda is it scales out for you, and you don't have to worry about managing anything. So you can just start throwing jobs at it, and it will just automatically scale out. And you can even chain Lambdas together. So you can have one Lambda. And another one of my customers, FINRA, is doing this. They have a validation process where they have one Lambda gets the initial file from S3, it chunks it up into smaller bits, and then calls subsequent Lambdas and farms it out. And all those Lambdas fan out and then process the file and do the validation, and then bring it all together at the end using DynamoDB for state. So anyway, very powerful serverless big data service that you should think about doing that if you have a use case that you can chunk up into small parts and then massively parallelize it. Lambda may be the way to go. Again, it's very cost efficient. You pay only for the requests served. So if you have, like, for example, these validation jobs, these may not be running 24/7. You have data that comes in a specific time window, and maybe it comes in at within a 2-3 hour window per day, and then the Lambdas will spin up and process it. But the rest of those 21 hours in the day, you don't have any infrastructure up and running to sit in there idle waiting for data to come in. So while they're just sitting there and nothing's happening, you're not paying a dime for your Lambda functions. You're only paying for the executions when the data actually comes in and you need to process it. All right, Amazon Kinesis. So Kinesis lets you collect, process, and analyze real-time streaming data. So another takeaway from this is oftentimes we think of big data as kind of a batch process. You get a bunch of data in, you churn on it, you do some ETL or some kind of analytics on it, you spit answers out, and you visualize it. But big data could also be coming from other sources, like maybe you're consuming Twitter, maybe not this audience, but maybe IoT devices. Maybe you have a bunch of IoT devices out in the field. You want to collect sensor data from that. That could very easily turn into big data. And so you can use Kinesis to bring that data in real time, either do some basic analytics on it in Kinesis itself, or stream it off to S3 for further analysis. Again, fully manageable and scalable. QuickSight. QuickSight is a BI solution. It has an engine called Spice, which is an in-memory engine to store your data, so you get really, really fast query returns. You can use QuickSight to set up queries and share those stories that you set up in QuickSight with other people, so you can set up an analysis and then share that with other people in your organization. It's about 1/10 the cost of traditional BI solutions, and it integrates with many other AWS services listed here. So you can see some of them: S3, Redshift, RDS, the various flavors of RDS, including Aurora. So again, if you store your data in your results in S3, for example, you can use QuickSight to pull that out and visualize your results. Glue. So data catalog and ETL, data catalog and ETL. This was announced at reInvent last year. Werner Vogels, our CTO, during his keynote presentation, announced this. This is in preview. It's not GA yet. It's in preview, and you can go ahead and on the console and sign up for the preview if you want to play with it. This is a fully managed data catalog and ETL service. So again, it's part of removing the undifferentiated heavy lifting that is around doing your big data analytics. It will actually help you build your data catalog for you. It can actually generate and edit transformations as part of the ETL, and you can actually also use it to schedule and run your jobs. So there's multiple pieces to this, components to this, to help you do your big data analytics and manage that stuff. I'm actually very excited about this. I'm looking forward to it coming out as GA. All right. So as a segue into the next part of my talk, just some questions about the volume, variety, and velocity at which data is being generated in organizations today. I'm not going to read this whole thing to you, but the last two: why is data distributed in many locations? Where is a single source of truth? And is there a way I can apply multiple analytics and processing frameworks to the same data? So one of the problems we have in organizations, you've got silos of data, and you have analytics run on this set of data, this analytics run on this set of data. Wouldn't it be nice if we had all of our data in one place, and then we can run multiple different types of analytics on that one big set of data? So that goes into an S3 data lake. This term has been very popular, and there's different definitions of this as well. But this is the concept to basically store and analyze all of your data, structured and unstructured, in one place, centralized location at a low cost. And obviously, I'm going to tell you that probably makes sense to be S3. So quickly ingest your data without needing to force it into a predefined schema. You basically apply the schema at the time of analysis when you're reading the data off of S3. And separating storage and compute is a very good best practice. All right, so what does that look like real quick? So it starts with S3. You put all your data in buckets in S3. And then using these ingestion tools that I mentioned, so we've got Kinesis, Firehose, Direct Connect, Snowball, even maybe database migration service, or just the straight S3 APIs and CLIs and SDKs. However you want to get the data in S3, we have many tools to do that. And then once the data is in S3, that's when you can analyze it. So you can use Athena, EMR, QuickSight, Redshift, all these tools I just mentioned. And again, you don't have to use all these. If you just want to start with Athena, serverless, just put your data in S3 somehow, either through Direct Connect or Firehose or whatever, and then just start querying it with Athena. You can do that very simply. Not a lot of cost. There's no upfront cost. Just pay for the queries that you do in Athena and the storage you do in S3. Very simple to get started. You can set up Dynamo and Elasticsearch to catalog and search the data you have in S3. You can write programs on top of it using API Gateway and Directory Service Incognito. You can write your own APIs to give your analyst access to the data in custom applications if you'd like. Again, hitting that same source of truth in S3. And finally, of course, you want to protect and secure that data. So using KMS and CloudWatch and CloudTrail, and again, there's other sessions to go into depth on all these tools. But basically, use these full suite of tools. And so it looks like a rather complicated picture, again, when you have your full data lake up and you're using all these tools. But I do want to reiterate, again, if you take nothing else away, you can start with something very simple: S3 QuickSight, S3 Athena. Just get started with that. Very simple. Pay for what you use, and then grow as your needs grow and you get more sophisticated. I'm not going to spend too much time on this. This is just pointing out that if you start small, remember on AWS, you only pay for what you use. You don't have to buy anything up front. So there's very little penalty to starting small. So if you know that you want to start with maybe a terabyte of data, but maybe you're going to grow that to 20 petabytes of data over the next 3 years, don't size anything for 20 petabytes of data. Start with that 1 terabyte that you have today and then grow into it. Because, for example, if you want to add 500 terabytes of storage, you could do that instantly on EBS or very quickly on Redshift, for example. Whereas if you're trying to do that on-prem, that might take a couple months. In government, you're probably talking 6 months realistically. So one really nice thing about this, the whole point of this slide is start small because there's very little cost to growing after the fact. It's very easy to grow, very, very different from your on-prem environments where you're going to do lots of multiple months of planning and justification in order to do some of these things to grow into very large data sets. It's very simple to do in AWS. Start small and then grow into it. Okay, so to reiterate before I hand it off to Ranga, use only the services you need, scale only when you need to scale, pay only for what you use. You can use reserved instances and Spot to save money. Security, use our security tools. There's plenty of tools you can use with CloudTrail and CloudWatch and even with config for visibility and control into your APIs and retrievals. Do encryption at rest. We have KMS and just button clicks to encrypt data at rest on S3. You can scale very fast, up to exabytes of data on S3. Again, big data doesn't mean just batch, and you can mix and match. The second point down here, you can do both on-premises and cloud. You can do some of your jobs on-prem, other jobs out into the cloud. You can actually burst capacity from on-prem into the cloud. So you don't have to just pick up everything and move it in the cloud all at once. Using our Direct Connect service and some other features that we have with VPC and some of our other tooling, you can actually do hybrid environments. You don't have to do a big lift and shift and do it all at once. And my final slide, I've been going to all the native AWS services. I also wanted to point out that we have a very big ecosystem of partners and vendors that also have tools that you may be using today that also run just fine on our platform. So C3IoT, who introduced this session, they were born on AWS, and they have a whole suite of tools that you can use from their platform that runs on AWS. But if you use, for example, I don't know, Tableau or SAP or SAS or any of these things, or SAP HANA, all that runs on AWS too. So you have all of the AWS built-in native services. But if you have other tools that you are already using today, you're welcome to use those. They'll all run wonderful on AWS, and they integrate with S3 and these other tools that we have. So with that, I am going to hand it off to FINRA, and Ranga is going to go into details of how they set up and do their big data processing on AWS. There you go.
Thanks, Bob. Hello, everyone. My name is Rangaraj Gopal. I'm a senior director responsible for enterprise data platforms. My group primarily deals with bringing data into FINRA, ingesting it, processing, ETLing, and publishing it to other consumers within FINRA. In this session, I'm primarily going to speak more about the big data ingest and validation. So I will provide we'll talk about how we use S3 for storage and management, and talk more about how we use EMR on S3 for all our ETL and data processing, and also a few slides about how we use Lambda for our serverless data validation. For those of you who doesn't know who FINRA is a financial industry regulatory authority. We are responsible for regulating. We are a not-for-profit organization responsible for regulating about 650,000 plus brokers in US and about 3,800 plus brokerage firms in US. To do our regulation for the stock market, we monitor about 99% of equity exchanges data, and also more than 2/3 of options exchange data. We reconstruct the market based on the data that we receive, and then try to find out what happened in the stock market, and that's what we do as part of our market regulation surveillance. Our mission is investor protection and market integrity. Again, to do our market surveillance, we bring in a lot of data. So our peak data ingest is we get about 75 billion transactions into FINRA every day. And all the data is stored in S3, and we have about 20 petabytes of storage between S3 and Glacier in our AWS ecosystem. Briefly, I want to tell you about how things were before the cloud. So storage and compute were shared in a single set of data warehouse appliances. Storage was fixed, so anytime we have to deal with doing any kinds of massive reprocessing or any kind of historical data retrieval, storage is fixed. So we have to take the data that's currently in our appliance, move it to a tape, restore the one that's from the tape into our appliance, do some processing, and then put them back on the tapes, bring it back. So a lot of operational type work. Capacity was always monitored very closely. So technology was really getting in the way of analytics. So before getting into the AWS architecture, I want to just give you a couple of real examples on a benefit that we faced when we moved to the cloud. About 6 to 9 months into our cloud project, we finished a big data enhancement project. And then the business came and asked us, hey, now that the enhancement is looking good, can you do this for the last 2 years' worth of data? And we were just thinking about it. Hey, if we were not in the cloud, what should have happened? It would have probably taken us maybe 3 to 4 months to do the work. And in addition to that, we'd have to continuously work on our capacity. The production jobs are running, so we need to basically put them on hold, get the historical data processed. So a lot of operational headache would have been there. For the entire 2 years worth of data, which is quite large, we finished the entire processing in 48 hours. Just started on a weekend. It was available Monday morning, and we probably spent less than $20,000 in the whole processing. So it was an immediate benefit that we saw when it comes to doing horizontal scaling, using EMR. The other interesting example is we had a data set which roughly is about close to 10 billion records every day, which is a pretty big data object on our side. And in our on-prem environment, we were able to only keep maybe a week or 2 weeks, sometimes maximum 1 month of data. And anytime a business comes and asks us, hey, can I get a 1 month of this data set for 2 months back? We have to take the current 1 month's data out, put it there, and then give business the access to do their data analytics. So same object right now, we have about 2 years worth of data stored in our S3. So again, capacity is unlimited for us in S3. So when we moved to AWS, what was our primary principles? We wanted to make sure that we register and track all the data that we are keeping in S3, everything from the start to the end. And then we wanted to make sure that we have an archival copy, more like a CSV type copy that is kept in Glacier or in the West Zone, so that if we want, in case of a need as a disaster or something, we can actually take the archival copy and restore our processing. And then we wanted to keep all the versions of our data, so which was not possible in our on-prem environment. In the on-prem environment, we only kept the latest version, and all the prior versions of the data, we had to go back to the tapes. So here, in the big data AWS, we wanted to keep all the versions. Anytime our business asks us, hey, what was there 2 months back and what changed? We'll be able to do a very easy, diff processing and other things and give them the answer. And we wanted to secure and protect the data, and we wanted to partition the data in the right way so that performance, helps. So I'll go a little bit deeper into the architecture. Whatever you see on the bottom here, majority of the data that comes from outside our FINRA, it comes through FTP and comes into our FTP servers. We also have few customers, when we moved to the cloud, we asked them to directly send their data directly to the cloud. We developed an API which gives a temporary token back to the customers. Most of these customers that send directly data to our cloud, they have AWS CLI running on their side, and then they just push data directly to S3. And some customers still send it to the FTP servers. And we have a process, which you see in the middle of the picture there, which moves the file from our FTP servers into S3. And that central layer there, data management, which is our primary area for managing the data that coming inside and making it available to our applications. So we use a lot of EMR, S3, KMS protected. We run a lot of validation, normalization, like ETL type jobs, and graph processing. All those things are running using EMR architecture. And then data management is our centralized data management catalog system, which catalogs all the data, keeps the lineage between the data, keeps information about who is using the data, which consumer used what version, and then the data management, it's more like a metadata processing, makes it available to the consumer systems. The consumer systems are, again, mostly using some kind of an EMR-based processing to do more advanced batch analytics, or sometimes they're using Redshift to do more analytics, more like browser-based analytics, or using Presto for some ad hoc data querying by data analysts and power users. Use HBase for doing some graph processing, or Hive or Spark to do some Hive jobs or MapReduce jobs or some Spark jobs for ETL. So that's our current AWS architecture. And where is our data? So all data that we have, everything is in S3. S3 is our one source of truth. We keep all our S3 data is in East region. We constantly replicate to the West region. And based on our retention policy, we also push it to Glacier. And if we need data from Glacier, we take it back and put it in S3 and use it again. So everything in S3, storage is separated from compute. So how do we access the data that is in S3? So we have multiple architectures here. We have graph processing, which is actually recreating the market. Anytime an order is placed in the market, it goes to the exchange. And then at the end of the day, all those orders are sent to FINRA, and FINRA is responsible to recreate the market. So we have a lot of graph processing happening there, and that uses HBase on S3, HBase EMR on S3. We have a lot of ETL running, which is a lot of batch processing using Hive and Spark. That's again using EMR. Targeted queries using Presto. A lot of batch analytics, surveillance type applications using EMR, and machine learning, again, using our EMR platforms. So that's everything is in S3, and all these different kinds of graph processing, ETL, everything is running their applications on top of the data that is sitting in S3. So we have a lot of data. So always the question that comes is okay, where is the data? How many versions of each data we have? Where did it come from? Who sent it to us? What date they sent it to us? Did they send multiple copies? How long do we have to keep this data? So these questions keeps coming to our architecture team, and that's when during our cloud migration journey, we created the centralized data management platform, which is open sourced. So when we started our cloud journey, we used a lot of open source products in AWS, and we also wanted to contribute back to the open source. So our data management platform services is open sourced. You can go to the FINRA GitHub. It's named Herd, and you can actually download it and use it, and definitely give us a feedback. If you like it, happy to hear about it. So the data management really keeps a catalog of all the data that we have, which is behind the scenes. It's in S3, and then we keep the schema of the data that we have. We keep the versions of the object. We keep what kind of compression that we are using on this object, storage policies, retentions, who sent us the data, who is all using the data, which version they used, and it also gives us an ability to keep archival copies, and also actually have a shared metastore where we can directly run SQL on top of the shared metastore. So majority of the times, our SQL jobs that are using Hive, Spark, or any other SQL type engine, they can just directly connect using the metastore and run queries on them. Same thing about the data management. Again, everything is stored on S3. Bob covered about the 11 nines durability for S3. So All of our business definitions is kept in the data. Like every object that we have, we keep things like trade date, received date, which is the firm ID, all kinds of attributes that normally you think about in a typical table. It is actually stored as part of our data management. And we also keep the partition information. So we try to keep our partitions to maximum like 2 to 3 levels, depending on how we want to perform it. So all the partition keys are actually defined in our data management catalog. And then we also have like a DDL service where if a client application wants to get the DDL, so they can just make a get DDL call, which is REST-based, and then it will give the DDL back. And then we can actually go to our metastore and do a create external table, or like just do an alter table, add partition, and just run queries on top of those. We primarily use bzip for our compression, mainly because it is splittable. So we also had some gzip files in the past, but since gzip files are not splittable, it will be just running, like as many mappers actually as many gzip files you have. So we mostly are leaning towards using bzip for our compression. All our archival copies stored actually as a CSV, so that if our technology changes or something changes in the future, we should be able to easily restore the data and use it in our future technology, whatever it is, so that we don't have any proprietary format for our backup data. So from our optimization, so as I said, all the data is kept in bzip. So majority of the time, it performs quite well. Wherever the performance is something required, we convert them into an ARC file. And ARC is used for all our performance-based queries, and the bzip and golden copy used where performance is not like really key. And again, we partition the data in such a way that performance is improved. We are using ARC for our Hive queries and Presto queries and Spark SQL queries. But if you are using some other columnar format, it should work too. But we decided to use ARC. Again, going back to the same, we keep the data in S3 for processing. So we directly connect our EMR backed on S3. So when you run an EMR job, we start up, and then we just create an external table, and then we do a select on top of that. And then we do an alter table, add partition to add how many other partitions that we want to read. If I want to read like 1 month worth of data, we just do an alter table, add partition for 1 month worth of data, and then just keep running them. We use a lot of spot pricing for EMR. So for those of you that are not familiar with the spot pricing, you can bid for how much money that you want to pay for your EMR clusters. And we start bidding from 15, 20 cents per cluster, per EC2 instance on the cluster. And it could go up to like $2 or something like that. But majority of the times, what we have found is we are able to very easily run on the spot pricing without paying too much. As I said earlier in the beginning of my conversation, one of the big jobs that we ran in the entire weekend for $20,000, which I think we probably ran like maybe some 1,000, 1,500 EC2 instances in parallel for the entire weekend. And we probably bid about maybe 10 to 20 cents per EC2 instance during that time. So we use a lot of spot pricing. So definitely, we are saving a lot of money by doing that. We have a persistent metastore, which again, every time data is registered, the metastore automatically keeps track of the object names, table names, column names, data types, so that our querying systems that are using EMR, Spark, Presto, and Hive can query them, so that none of the systems, they don't need to know what is the column name or attributes or anything. Everything is coming from a centralized metastore. All our data is protected at rest using either AWS KMS or standard server-side encryption on S3. And everything is HTTP. All transit data is protected using HTTPS. We use a lot of, we have our versioning in our own data management system. On top of that, if we need, we also enable the versioning in S3 so that we can use the S3 versioning. And as I mentioned earlier, we back up to the West region and Glacier for recovery type reasons. Cluster sizing. So we actually try to size our cluster based on our job complexity, and EMR is normally charged at an hourly basis. So if our job finishes in 45, 50 minutes, we try to make sure that we can put some other smaller job in the same cluster so that we are very efficiently using the spot pricing. And you can also, do other things like, again, you can do a lot of things in EMR. For more like interactive analytics, we don't do spot because a user is coming into the browser and looking at the application. There, we actually plan our sizing based on some on-demand instances. Why did we choose Hive and Spark SQL? All of our legacy applications that we were using before moving to the cloud were all mostly SQL-based. So from a skill set perspective, it was very easy to do Hive, Spark. So we directly started using Hive, Spark SQL, and we were able to just quite easily migrate all of our code that's running on an on-prem environment to the cloud environment without much of a skill set issue and other kinds of issues. So we were able to easily manage it. I'm not going to go deep into the benefits of data lake. I think Bob covered it in his S3 data lake slide. I think the same stuff here. Our usage statistics on AWS. So this is an stats that actually I pulled for our something that we ran in the May one of the weeks in May. We are actually starting about 33,000 EC2 nodes per day, and about 90% of our EC2 usage is EMR-based, and we have 20 petabytes of storage in S3 and Glacier. All of our use is primarily in prod environment, 60% plus is in prod environment. Rest is in our test environment and dev environment. We try to keep all of our EMR-based jobs to run under 2 hours, and there are certain jobs where actually it runs more than 2 hours. The primary reason we wanted to keep it under 2 hours is if you are bidding on a spot price and if your job fails, you have to start over all again. So I think that's why we try to keep it that way. This is one of the stats from our processing. As I said, my team is primarily responsible for doing ingesting, validating, and normalizing the data. And you can see there we have about 1,000 plus jobs running on the ingest, 150 plus on validate. So a lot of data files that we are processing, billions and trillions of transactions that are being processed, a lot of storage. This is a monthly data volume, and you can see that we are using close to 150,000 plus EC2 instances for our normalization. For our ingest, we are getting 10,000 plus. So a lot of EC2 EMR used by us, and you can see the compute hours that has been running, and that's most of, I would say about 90% of those compute time is spot-based. I want to quickly talk about how we perform validations using Lambda. So before we moved to the cloud, we had an on-prem validation service, which the files used to come, and then they are queued for validation. And these are actually about, I think, 3 to 4 billion transactions that are coming in every day. And our SLAs are very tight. The jobs are running 24/5. And any time there is a backup or something else is happening on the infrastructure, the jobs are slowed down. So a lot of problems maintaining the on-prem solution. So we moved to a Lambda-based AWS solution. Files come into FTP servers, and then they are copied to S3, and there's a small EC2 instance that runs our controller, and it keeps calling Lambda. It keeps starting Lambda for each of the files, and our goal was to finish our Lambda job in less than 1 minute, and it horizontally scales, beyond what we can think of. So we don't run any more 24/5. Anytime the file comes in, it goes. Lambda is started, the file is validated, and given back. So it was a huge advantage for us for this whole validation service which we used to pretty much run 24/5. I think nowadays it probably runs only 4 or 5 hours in a day, depending on when the file is arriving into us. So again, our results there, reduced cost, processing times have reduced. Again, we were able to give feedback about the errors back to our providers in a more granular way. Because of our on-prem solution, we were not able to scale. We didn't do validation at every column level. But in the case of our cloud implementation, we were able to validate at every single column. It's about 3 billion records a day, horizontally about 200 columns for each of those rows. So a lot of validations were running. So the scaling, horizontal scaling was, like pretty amazing. So when we moved to Lambda, it was quite easy for us because our original validation program was running in Java. So we were able to easily port it to our Lambda-based architecture. So where are we going to go from here? We are trying to move all of our Hive-based ETL jobs into Spark. We started about 3 years back. So a lot of Hive jobs at the time. So Spark is more matured now. So we are moving all of our Hive ETL jobs into Spark. EMR actually has some new concepts called instance fleets, where you can actually better pay for the spot pricing so that you have less risk of losing a EC2 instance when a critical SLA job is running. And then within our FINRA, we wanted to move our ETL services to other areas of FINRA where it's not just big data. Even if it is a small data processing or other kinds of data processing, we wanted to use our ETL framework there. So that's our future plans to use. Thank you. You want to take questions here?
We have 3 minutes if you want to take some questions. And we'll also be outside after. But we can take a couple right now, and Mark's got a microphone.
So when you have an SLA you need to meet, it sounds like you don't really turn the dials on which instance you're going to run on. You just put it in Lambda, and away it goes to complete really quickly. Is that accurate?
Yeah. So when I meant an SLA, we were supposed to give feedback within 2 hours to our center of the data. So if the jobs are waiting, sometimes we miss SLAs because we are not able to send the feedback within 2 hours. But once we move to Lambda, as a file comes in, the validation is kicked off, and within 10 minutes, the validation is normal. The feedback is given back to the center of the data.
Okay, one more question. So FINRA protects investors, basically. You guys recently released a report that talked about the liquidity of securitized transactions. Did you have to dive into a lot of your data analysis to determine what the liquidity is of these securitized packages? Is that one example of some of the things you do?
More easier for me to answer more like tech-type questions. I think there are somebody from our CorpCom to more answer those kind of questions. I probably have to redirect to them. So if it's a more techie question, I can answer. Sorry.
Hey, did you consider Redshift for any of your purpose, and is there a reason for selecting EMR?
So we use Redshift also in FINRA. Actually, there was a presentation yesterday for Redshift by FINRA. EMR is mostly used for all of the ETL processing, those kind of things, but Redshift is used for our interactive querying, where we need to give pretty fast feedback to the end users. So we are using Redshift for those kind of use cases.
Okay, thank you.
Okay.
Okay.
We'll cut it off for now. We'll stand outside the door for a few minutes if there's other additional questions.
Thank you.
Thank you.